start to catch up to you.
It's about time, Jeff.
All right. So, again, part of the stuff we're doing at first is just getting used to the chart itself. The last problem is finally putting it all together, making a real confidence in it. This first problem, degrees of freedom, is 5. All right, and then it's 99% confidence. So what percentage is outside? 1%. So I know to use this column. And like I said last time, just to really reinforce this, if I stop somewhere, I get a t-score. If I go all the way to the bottom, I get a z-score. That's part of this that we talked about last time. So I'm going to use this column and stop at 5, 4.032. So is that kind of big? Remember, t-scores are basically the same idea as z-scores. So would that be kind of big? A z-score of 4 would be kind of big, right? Why is it so big? Because my sample's so freaking small. My sample's so small, how certain am I about anything I find from it? Not very certain. That's why the t-score's got to be bigger to cover my ass for my extreme uncertainty. If my sample got bigger, 4.032, if I made a bigger and bigger sample, what's happening to my t-score? It's getting smaller because it doesn't have to cover my ass so much. If I have a bigger sample, I'm more sure about what I see. So the t-score's job is less and less crucial. It can get smaller until it finally becomes a z-score when my sample is large. You gotta love that shit. What's large? Depends on your situation. All right, what about this one? This degrees of freedom is 100. What's my alpha? 10%, 0.10. So I know I'm looking here. There you go, Jeff. 0.10 and 2 tails. And I'm just going to stop at 100. 1.660. Kick ass. I like that later. We should get a 2.6601 later. I would like that. Oh. This is the first one that was a little bit freaky, but I want you to realize a general idea in statistics. Anytime there's some more uncertainty in what I'm doing, I have to penalize myself for that. So if my degrees of freedom I'm working with is not on the chart, I have to go to the next one down from that numerically. So in this case, degrees of freedom is officially what? 92. What's the next one down from that 90? That's actually on the chart. So even if my degrees of freedom was 97, it's not on the chart, I go to 90. If you use 100, I'm not going to kill you for that, right? I'll just maim you. Okay, I'll still be able to walk around. So if I go to 98%, which column am I going to use? 2%. And then I just stop at 90. Bam, 2.367. Somebody pointed something interesting out. See how they're changing by 1 right here? And then they start changing by 5. And then they start changing by 10 and 100 and 500. Because they're not changing very much at that point. It's a lot like on the z-score chart, how 3.41 and 3.42 are both like 0.0007. There's very little area, weigh the shit out at 3 standard deviations. Sort of the same idea, to be honest. So I just forgot what we did. We got where are we? Oh yeah. So we got 2.368. All right. If I wanted to then construct a confidence interval, which I didn't ask you to, I didn't give you enough information, I would just put that number right where I would normally put a z-score. So work-wise, this doesn't change a damn thing. I'm just looking at a different chart to get the score to put in there. I like it. Which one of these can you not do on number 2? C. It's not normal. Does the sample size save me? No. You suck. So it can't be done. No. Looks like I'm just like, no, I don't want to do it. Up here, n is not greater than 30. Oh shit. But I just say it's normal, so it doesn't matter what the sample size is, right? So I know I can do something. Check. What is it that I can do? What do I check now? What do I use, Z or T? What do I look at? Y, Z. What do I look at? What type of standard deviation do I know? So I get way too many people that just say, I can use a Z-score because I know the standard deviation. Which standard deviation? In this case, I know the population standard deviation, right? That's what sigma means. It's a Greek letter, population. Therefore, that's why I can use a Z-score. And I want you to, what's the Z-score going to be? Well, here, I'm going to use the T-score chart because I'm crazy. 90% confidence. What's alpha? 10%, 0.10. So I'm going to do here. I want a Z-score, so I'm just not going to stop. Make no party like a Z-score party. Go all the way to the bottom. There's my Z-score. So in the future, if I ever go to the T-score chart to get a Z-score, don't freak out. Z-scores live at the bottom. Because it's a large sample, therefore I don't need my ass covered. I could just go ahead and use the Z-score chart. I mean the Z-score number, right? So I get 1.645. That should definitely sound very familiar. Yes?
Isn't that if you're like a 95%
What do you mean?
confidence for like the 1.6?
No, definitely not. Why do you think that?
Because that's what it is on the Z-score chart.
Ah, okay. So when I look up 1.645 on the Z-score chart, which I do have one. Let's see. Oh, here. I really want to put this to rest. If you look up, what was it, 95%? 90%. So if you look up 0.90 in here, I am not doing the right thing already. That is 90% where? All the way down. And I'm supposed to get the one that's got 90% in there. Yes. So, real quick, I want to put a point out. You can't find confidence level numbers in here because it's not getting you the confidence level. It's supposed to be inside, not forever down. So the 90% confidence level is 1645. Because again, how did we do it? Well, what's going to be out there? 5%. And if I look up 0.05 in here, that's when I get, bam, 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 1645. I like it. Sorry.
So what I did was, I used the Z-score table, but
Sure.
I did it with like the area to the left. So
Sure.
It gave me a negative.
Of course.
Z-score. So would you mark us wrong?
Yes, all day long. But not like a crazy amount. Why would I do such an evil thing? The negative, there's a negative and a positive, right? The plus and minus is built in. So this value should just be the number. Not negative, just the number. We happen to look up the Z-score, the negative one. I always hope to God you guys are semi with me. So remember, this one was 0.05 there, right? And 0.90 is in here. So if I want to look up the positive Z-score, what area is below it? 95. So if I look up 0.95, then I will get the correct Z-score, which again is 1.645. So what I'm trying to get you to realize is, you know you have to be able to use the Z-score chart. I'm going to ask for a 93% confidence interval or something like that. And that number don't exist on anything. So you got to be able to look it up the old-fashioned way. But the T-score chart gives me much more detailed stuff to find a Z-score, any Z-scores. These should all look, almost all of them should look familiar. This one maybe not. But this one is really close to 2575. It actually just improves on it, makes it a little more perfect. Remember 2575 that's come up for a 99% confidence interval? If you don't remember that number, it's okay. You know, obviously I know some stats. I'm gonna have these numbers in my brain, but that's come up before. All right. What about this second guy? It says it's not normal. Shit. Well, why is it still okay? And it's greater than 30. Check. So I can do something. What is the thing I can use? I have to use a t-score because I don't know. I have to use a t-score because I don't know population standard deviation. T-scores were invented to cover my ass from when I only know S. I don't know sigma. That's why they were invented. What's my degrees of freedom? 38, one less than N. Which column am I going to look in? 98%, so what's alpha? 0.02, 2%, so 0.02, and I want to stop at 38. So 2.429. Coolness. T-score is 2.429. This one we already said no to. This one is double good, right? It's normal already, and then the sample size is like, all right, well, I had you, just in case. So I know I can do something. Check. What is it that I have to use? T-score. So what's my degrees of freedom? 60. In which column am I going to look in? First one, because alpha is going to be just 1%, and I want to stop at 60. Yeah. Where the hell are you? There you go. There's that 2660 I said was coming. Okay, I like it. So the meaning of a t-score is the same as a z-score. It's just what I have to use when I only know S. When there's something about the problem I don't understand, that I don't have the right value for. It covers my ass for that. Number 3 is finally a full-fledged problem. What did you guys get for the sample mean here? 286. So let's say 2.829. I like it. I'll tell you on a test how much to round to because it's not always obvious. If you make it 3 places, it's fine too. Yeah. Do I use this?
No.
Hell no. Why not? It's a sample. So students get confused because I think I've said in here before that there are problems in the homework that give you both sigma and S. Those are things we know. So in that case, I'm never going to frickin' use S. I'm going to use frickin' sigma. It's the better one to use. Then you could argue, but Jeff, look, my calculator gave me both. No, it didn't. If you put those numbers in, what is it you're putting in? A sample. Which one of those is valid at all? S. Why does it give me both then? This calculator don't know what it is. It's just going to give you both. Here, pick human. Just a dumb calculator. Leave me alone. So it's going to list both sigma and S, but we know it's a frickin' sample. We have to use S. Right? The calculator doesn't magically know what the whole population of grades are. That would be worth, that's like $4 million for this calculator that knows things about the universe. What do you guys get for S then? That's the better. That's the one you got to use. 724? Is that what you guys got? Yeah. Okay. Make sure you can do that. Because you know I'm going to give you problems like this. And now, now, how do I get the t-score? I want 98% confidence. What's my degrees of freedom? 6, because my sample size is 7. So what's my t-score going to be? What's alpha? 98% confidence. So what's alpha? 2%. And then I want to stop at 6. So 3.143. I saw that on a few papers, so that made me all happy. And again, we looked at a different chart to get that, but the work is the same. It's the mean, where'd you go? Plus or minus the thing that acts like a z-score, a little bit bigger to cover our ass. Standard deviation divided by square root of n. And again, one of the biggest mistakes, easy mistake, is to put a 6 where there should be a 7. Right? The only thing this does is get me to t. You might even want to cross it out when you get t. Just forget about it. It's supposed to be n in there. What do you guys get for the error? Error. 18.679. Let me see if I can get the same thing. Good job, John. So I got 78.29, give or take 18 point. No, Jeff. You're almost doing it, buddy. 18.68, roughly. I think I showed you this. Not an important thing. But if you store that in x, I can then do 78.29 minus x, 78.29 plus x. Very easy. So I get 59.6 up to basically 97. This is grades, right? This is grades. If somebody came to me and said, I've done a study, and I could say with 98% certainty that the interval 59.6 to 97 has the real average grade, is that useful? Is that at all useful? I already knew that. It's somewhere between an F and an A. Thank you for that. Thank you. So what I want you to realize is just because it's not useful doesn't mean any of our work was wrong. But when I get there and I'm like, well, shit, that doesn't tell me anything. What could I do to improve my study? What's the most basic thing that's wrong about this study from the beginning? There's only 7 in your sample. Way to go. So I should expect my results to suck. Well, it took 7 grades. I'm going to end up not knowing shit. So if I do this, I'm like, well, that's obviously not good enough. I'm just going to take a bigger sample. Yes?
When we get to that point, I thought that we were supposed to write the statement.
Yes, we're going to write the statement right now. But I just want to make sure everybody understands what's wrong with that interval and why it's wrong. Nothing to do with our work, but it's still informative. So how would the statement go that I have to write at the end? We are 98% confident that the interval (59.6), in this case is not really units, contains the true mean grade, right? And they didn't really give us a population, so that's all you got to say. So what I want you to really, really realize is the work we do for the confidence interval is not different just because I'm using a t-score. It's the same work. It's just I'm getting this number from a different chart. So now I'm going to unleash you on the other side. What I want you to do, you could work with one other person if you want to. You can work by yourself. I've got my instructions there at the bottom. Everybody see this side? Right? Everybody's got that, you know. When you pick 20 grades from all these grades, please try to ensure that it's a random process. Because if I just get everybody picking the first couple rows, that's not going to do shit for me. And you're like, why do I care about what it does for you? Because I'm the teacher. So please, drop a pen and pick those numbers. Pick every 10th one. Ooh, systematic. Figure out a way to make it random. Don't just pick all the 90s. That obviously is a skewed sample. But my average was really high. You guys understand what's happening. So work on this side now. The very first thing I ask you is pick 20. Get a sample of 20. Try to make sure it's truly random. You can work with one other person if you want to. And here's a really exciting part of all this. When you get your interval made, I want you to come up and write it up on the board. So before you come up here, you can always check with me if it looks okay. Bless you. People are 6, 8, 32, 33. Okay, I got a few more than I need. Let me know if you need some help.